there have been many improvements to the tool axis smoothing functionality in FeatureCAM 2013, including the addition of a new smoothing parameter for collision avoidance. This new parameter eliminates any sudden tool axis changes and ensuring a smooth transition when a collision avoidance takes place. In this example, you can see we have this aero structure, and we also have a clamping system that's held it down. What we're interested in doing is doing an isoline operation on this surface here. Now traditionally we would probably choose a vertical tool axis to try and machine this part, but you can see we have these two tabs sticking out of that surface that we need to avoid. To do this, what we've created here is an isoline operation, and under the 5-axis tab we've instigated the tool axis avoidance, collision avoidance, using a lean then lead operation. If I uncheck the two latter toolpaths and just simulate this first toolpath, so you can see the tool comes into position. If I choose Alt F3 just to simulate this toolpath, so we start off vertically, making our way through the part. If I continue to play this down, as we get further and further down the component, maintaining that vertical position. However, as we get to the tabs, you can see we get a sudden change in the tool axis as the tool tries to avoid colliding with those tabs. This continues all the way down the part. If I continue to play the simulation, we can see the sudden tool axis changes. To avoid this, we have a new option, which is the smoothing distance. I'm going to turn off the first toolpath and look at the second toolpath. You can see here it's marked as smoothing distance 20 mm. Going into the operation, into the isoline, note we have the same collision avoidance option, only we've set a smoothing distance of 20. In this case you can see we've got the tool axis smoothing set on. Under the tool axis smoothing we've got a smooth azimuth and elevation, and in this case we've set a correction of 5 degrees with that smoothing distance of 20 mm. Playing this toolpath, again you can see we get the same vertical moves at the starting point of the toolpath. Then as we get into the collision region, you can see we get a much smoother transition between the vertical orientation and our collision safe. This smoother transition prevents the chance of any witness marks or chatter from the tool by forcing the machine to move too quickly. We could go further still. In this case you can see we've got a third toolpath that's marked with a smoothing distance of 65. In this case, if I measure a horizontal distance between the two corner positions, you can see we have 128 mm, so we've set a smoothing distance that is roughly half that value. If I go into this operation, into the 5-axis, you can see that same smoothing distance, 65 mm. The difference with this toolpath, if I play the vertical sections first, So again, you can see the toolpath is the same. However, as we get to the collision region, you can see the tool maintains that orientation as it goes past the two tabs. This means that the machine moves in a much smoother, more consistent manner. This new look ahead parameter will greatly improve the motion of the machine. To verify this, we can look at this on the machine itself, clicking on the machine simulation, rotating the model round, just hiding the case of the machine. We can play this simulation. So note the tool is vertical initially, then it tilts over and starts to machine at that angle.